Okay, ladies and gentlemen, let's talk about independent and dependent events. Now, the first thing we're going to do is we're going to start with this example. A sales advertises that if you buy an item from the left column, you get a free tote bag. Suppose you choose items at random. What is the probability of buying a beach towel and receiving a red tote? Well, here's the deal. You have a beach towel would be 1, 2, 3, 4, 5, 6. So if there are 6 options, the beach towel is a probability of 1/6. Now, to get a red tote bag, there are 1, 2, 3 options. So for a red tote bag, it's going to be 1 out of 3. Now, it says, what is the product of the probabilities in exercise 1? Well, product means multiply. So I'm going to take 1/6 times 1/3, and that's going to be 1 over, because 1 times 1 is 1, 3 times 6 is 18. 1 over 18 is the product. So, whereas getting a beach towel is 1/6, getting a red tote is 1/3, getting a beach towel and a red tote would be 1/18. Now, you can draw a tree diagram. That tree diagram would be, for every t-shirt you get green, red, white. For every jacket, you would be able to get green, red, white. For every hat, green, red, white. And you'll notice there's going to be 3 options here, 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 also known as 6 times 3, which is 18. So, but your tree diagram would have something split into 3 branches, another 3 branches, another 3 branches, on down. But that'd be a pretty big tree. Now, using all of that, what we want to do is we want to move on down. Okay, what we just saw was an example of compound events. A compound event is something that is 2 or more simple events. So in our case, we had the beach towel, then we also had the tote, the color of the tote. These events were independent events because you can't be getting a beach towel and a tote at the same time. So compound, beach towel and red tote. So we had beach towel and red tote, but they were independent because the beach towel wasn't red and the tote wasn't a towel. They were separate. They were independent events. So finding the probability of one event and another event is the probability of one event times the probability of another event. Okay, so now that we've taken a look at some of those, let's see if we can do a few more things here. Independent events. If I have these tiles and I have this spinner, 1 letter tile is selected and the spinner is spun, what is the probability that both will be a vowel? Okay, well remember, vowels are A, E, I, O, U. So A is a vowel, E is a vowel. So the chances of getting a vowel from over here is 2 out of 1, 2, 3, 4, 5, 6, 7. 2 out of 7. The vowel over here, we have a vowel and a vowel for A and E, and that's going to be 2 out of 6. So selecting a vowel from the first one is 2 out of 7. Spinning for a vowel is 2 out of 6, or 1/3. But if I want both, that means and, I'm going to multiply 2 7s times 2 6, and I'm going to come up with 4 40-seconds, whereas they show reduces to 2 21sts. Okay, so again, we're putting things in combination. Now, we've already talked about independent events. Let's talk about dependent events. Whereas independent, 2 things can go off on their own. Dependent means those 2 things have to happen together, okay? So in this case, let's say I have a bag of marbles. And those marbles, I got 4 red ones, and let's go 1, 2, 3 blue ones. Okay, what's the chances that I draw a red marble? Chances of a red marble would be 4 out of 7. 4 out of 7 because there are 4 red marbles out of 7 marbles total. Now, but the thing is, what are the chances that I draw another red marble? What are the chances that I draw another red marble? Instead of 4/7, well, one of those marbles is now gone, and I have only 3 red marbles, and I've already pulled that marble out, so there's only 1, 2, 3, 4, 5, 6 marbles left, 3 out of 6. So to get 2 red marbles, one would be 4/7, because there's 4 out of 7, and then 3/6, because there's now only 3 out of a total of 6, 3/6. So to put those together, I come up with 12 over 42, and then reduce it. You'll notice that these are dependent because this number here, the 3 and the 6, depend on what I got the first time. So it all depends on how it goes. Now, let's do this process again. Let's take my same bag. Okay, and I still got my 4 red marbles. And I still got my 3. I still have my 3 blue marbles. And this time, I want the probability of getting a red. But let's say the probability of getting a red is 4 out of 7. Okay, 4 out of 7. Pull it out. Now, what's the probability of getting a blue marble? Well, a blue marble, I still have my 3 blue marbles, and it's 3 out of 6, because even though I didn't pick any of the blues the first time, there went from 7 marbles, now there's only 6. So again, I got to put those together and multiply. They're dependent. Unlike my spinner and my tiles, where stuff was separated and different, these were together. Now, here we go. We have fruits. What's the probability of getting 2 bananas? Well, if we're dealing with 2 bananas, how many bananas do we have? We have 7 bananas, 4 oranges, 5 apples. So what's the chances of getting a banana? Well, let's see here. There are a total of 16 pieces of fruit. 7 of them are a banana. But as soon as I pull out one of those bananas, I now have 6 bananas left, and there's only 15. So again, it's dependent because I didn't put the banana back in. You don't put fruit back in. Okay, so now let's see if we can go on a little further. We come down here and we say a penny is tossed and a number cube is rolled. Find the probability of a tails and a 3. So let's think about this a little bit. Is this independent or dependent? Well, the answer here is they are independent. The reason they're independent is because whatever I get on the cube has nothing to do with whatever I get on Abe Lincoln's head. Okay, that's Abe Lincoln's head, not an egg. So this is separate from this. So I have a chance of 1/6 and a chance of 1/2, and I just multiply it together. Now, if I go to heads and odd, well, heads, it's still 1 out of 2, but how many odd numbers are there out of 1, 2, 3, 4, 5, 6? Well, 3 of the 6 are odd, so I multiply them together and I get 3 over 12, which is 1/4. Now, here's a sneaky one. Number 4, a card is drawn from the card shown. A card is drawn from the card shown and not replaced. Then a second card is drawn at random. Find each probability. What's the chances of 2 even numbers? Well, here's even, 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 even. So that's 4 out of 9. Now, the problem is if I draw one of those even numbers, doesn't matter which one, but one of them, I now only have 3 even numbers out of, and now that one's gone, so there's just 8. So that is now dependent rather than independent. All right, so using all that, we need to try to do this homework for today. Now, your homework for today is going to be page 452, and let's go 1 through 21. 452, 1 through 21, all. 1 through 21, all. Now, that's part of your homework. Make sure you write that down. Additionally, we need to go back and I want you to practice a few of these other pieces. On the mid-chapter self-check. So, make sure you also do page 448, 1 through 12. 448, 1 through 12. Okay, that's what I have for you today. Make sure you have all that done by tomorrow.